Hey everyone, it's Justin again. For my next backyard project, I'm putting up a fence around 3 sides of my backyard. I found a property map of the neighborhood, and it shows my backyard is a square with an area of 2,500 square feet. All the sides of my backyard are the same length, so if we find the length of one side, we can multiply it by 3 to find the total length of the fence. So, how can we find the length of one side of my backyard? Just like my previous projects, we could take the square root of the area to find the side lengths. So let's take the square root of 2,500. Oh, that's a big number. I'm not sure I can think of a number that squares to equal 2,500. Maybe we could find another strategy to make this problem a little easier. Since I don't know what squares to 2,500, is there another way I could write the number that's easier to work with? Well, 25 times 100 equals 2,500, and smaller numbers are easier to work with. Let's rewrite the radicand, that's the number or expression under the radical, as 25 times 100. 25 and 100 are perfect squares, so we can take their square roots. Do you think the square root of 25 times the square root of 100 equals the square root of 2,500? Well, let's find out. What are the square roots of 25 and 100? The square root of 25 is 5, and the square root of 100 is 10. Now we can multiply. 5 times 10 is 50. Do you think 50 is the square root of 2,500? How can we check? We can square 50 or multiply it by itself. 50 times 50 is 2,500. That means the square root of 2,500 is 50. So, for square roots, we can rewrite the radicand as factors and split the radical into the square root of each factor. Then we can evaluate each square root and multiply their results together. Since the square root of 2,500 is 50, my backyard has 50-foot sides. For the total length of fence on 3 sides, we multiply 50 by 3, and that's 150. So I need 150 feet of fencing for my backyard. In past backyard projects, we had some numbers that weren't perfect squares, like 20, and we couldn't take their square roots easily. But if I could break 20 into 2 factors like we just did with 2,500, maybe we could simplify the square root of 20. Let's try it. First, I need 2 numbers that multiply to 20. Like 2 times 10 equals 20. We can rewrite the square root of 20 as the square root of 2 times 10. This is equal to the square root of 2 times the square root of 10. Just like before, let's take the square roots of 2 and 10. And what does that give us? Oh, wait. 2 and 10 aren't perfect squares, so their square roots aren't whole numbers. This didn't make our square root any simpler. Can you think of any other pairs that multiply to 20? 4 and 5. So let's rewrite the square root of 20 as the square root of 4 times 5, and then break it up. Can we evaluate either of these square roots? Yeah, the square root of 4 is 2. 5 isn't a perfect square though, so we'll have to leave it the same. Even though we couldn't completely remove the radical, we were able to evaluate part of it, turning the square root of 4 into 2. Radical expressions are written similarly to numbers with variables. Just like 2 times x is written 2x, we write 2 times the square root of 5 without the multiplication symbol, like this. That's because when no operation is written between terms, it means they're multiplied. And just like the number is written before x, we write the number outside the radical first, followed by the square root. We can read this expression as 2 square root of 5, or even just 2 root 5. This process, rewriting the square root of 20 as 2 root 5, is called simplifying the square root. Even though this answer might not seem simple, simplifying a square root can help us better understand the number's value. It's easier to work with numbers that aren't under a radical symbol. In this problem, we took the square root of 4 to get 2. Smaller numbers are easier to work with too. Notice how we started with 20 inside the radical, and now it's 5. That's what simplifying does. It makes the radicand as small as possible, giving us some numbers outside the radical instead, all while keeping the number's value the same. Since simplifying the square root of 20 didn't change its value, we use an equal sign. Well, now I'm wondering, why did using 4 times 5 work better than 2 times 10 to simplify the square root of 20? And what does that tell us about which factors to choose when simplifying a square root? Pause the video to write down your thoughts in your guided notes. 4 times 5 worked better than 2 times 10 because 4 was the only perfect square, and we can evaluate the square roots of perfect squares. So, when we're choosing factors of the original radicand, we should choose factor pairs that include a perfect square. All right, sounds like it's time to try a few examples. To simplify the square root of 18, we need 2 numbers that multiply to 18. Pause the video here to list the factor pairs of 18. Here are our factor pairs. Ooh, 1's a perfect square. Can we use 1 times 18 to simplify? Pause the video to try it. Yeah, since the square root of 1 is 1, and 1 times anything is just itself, we end up with the square root of 18 again. So, will using 1 as the perfect square factor ever be helpful for simplifying square roots? Pause the video to write down your thoughts. Using 1 as a factor will always bring us back to the square root we started with. So no, 1 won't help us simplify. This means we need a different pair of factors. Which should we choose? 9 is a perfect square, so let's use 2 and 9. We'll rewrite the square root of 18 as the square root of 2 times 9, and you can take it from here. Pause the video to finish simplifying. How'd you do? We could split this up into the square root of 2 times the square root of 9. What's the square root of 9? 3. We don't evaluate the square root of 2 since it's not a perfect square, so we're going to leave it as it is. Is this our final answer? Not quite. We need to write it with proper math grammar by writing the whole number in front of the radical and removing the multiplication symbol. 3 square root 2. Next, simplify the square root of 40. Pause the video to try it. Here are the factor pairs of 40. 4 is the only perfect square here other than 1, so we'll rewrite the square root of 40 as the square root of 4 times 10. Then split it up into the square root of 4 times the square root of 10. Evaluating the square root of 4 gives us 2 times the square root of 10. For our final answer, we just remove the multiplication symbol. And that's it. In both of these examples, even though our answers still included a square root, simplifying the square roots made the radicand in the answer smaller than the radicand in the original square root. Thanks for exploring square roots with me today. We discovered that a square root can be broken up into the square roots of its factors, and we found out how much fencing I need. Then we use that same property to simplify square roots of non-perfect squares. Be sure to finish up your guided notes and complete practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, finding a perfect square can make problems a little less radical. See you next time!